let's look at this question. A radio uses an inductor of resistance 200 ohm and inductance 2.5 microhenry and a variable capacitor in series as a tuning circuit. So I believe our concern here is on the tuning circuit, and this tuning circuit here probably should look like this. You have something like a circuit, then you have an inductor. Then besides this inductor, you also have a variable capacitor. So I draw this as my variable capacitor over here. Okay, so let's just list out everything we know. We know that the inductance has a resistance of 200 ohm. And we also know that the inductance is 2.5 microhenry. Okay. So we also know that the variable capacitors don't really have a specified capacitance because the word variable means by you can actually change the capacitance. So the capacitance is not fixed. So I'm not sure what's the correct symbol to really show that this thing is variable, the capacitance. But one, I can help you to visualize how are you able to change the capacitor's capacitance in a circuit. So you might be able to adjust one of the plate while keeping one of the plate being fixed. So in that case, if you are changing the distance between the two plates, you are actually changing the capacitance based on this formula over here. So let's say if you increase the distance of separation between the two plates, essentially you are bringing down the capacitance. So this is one way we can change the capacitance of a capacitor. Okay, so it mentions here in the second sentence that the capacitance of the capacitor is varied until the resonant frequency of the RLC circuit equals the frequency of a selected radio station. Okay, so I think to explain this sentence, right, I will need to tell you how a radio works. So how does a radio works? Let's say today here I have something like a radio. I hope you all are still familiar with radio and not just Spotify music or Apple Music. Well, this is a radio. In my generation, this is something very common. So when we are using radios, we need to tune our radio. And I believe based on this thing is our tuning knob. Okay, so how do we use a radio is, let's say you want to listen to Hits FM. Okay, let's say Hits FM is the one that you want to listen. If you are in Spotify, you might be able to listen it through the internet straight away. But in our times, you have to rotate this tuning knob until this meter over here move towards the correct value. In this case 100, right? So it should be moved towards somewhere here. Then when your red pointer moves towards this value here, then what you can hear from this speaker here will be what is being broadcasted by Hits FM. Okay, of course if you want to change it to, let's say, Era FM, then you adjust it until, let's say, here. Then you listen Era FM coming out from your speakers of the radio. So how does this thing work is, there's transmission tower broadcasting signals from these radio stations in the air. Okay, so your air is filled with radio wave. Actually, your air is filled with radio wave. Let's say you have 100.8 FM information about this. There's radio wave transmitting what is being broadcasted by that station in terms of radio wave in the air. And there's also 87.7 FM filling the air. There's also 102.4 FM filling the air. So there's all the frequencies of radio wave filling the air, but you can't be listening at all the radio stations at once, right? If you are listening to all radio stations at once, you'll be listening to a mess, a jumbled up voice basically. So let's say you want to be specific, you want to listen to this 100.8 FM over here, you want to listen to Hits FM. So what you do is you tune this tuning knob. So when you're tuning a tuning knob, right, what essentially you're doing is you're either changing the L or the C of the circuit. Okay, this is the traditional radio, not very electrical. You're either changing the C or the L of the RCL circuit. Okay, in this question here, you are changing the capacitance. But in many nowadays radio, they are actually changing the inductance. Okay, so in this case, if you change the C, you remember from the previous discussion on resonance, we say that resonance is equal to 1 over square root LC. So by changing the L here or changing the C here, if you change either of this, essentially you are changing the resonance angular frequency. So of course you also know that if you are changing the angular frequency at resonance, you'll also be changing the resonance frequency. So what are we doing when you are changing C is we are trying to change this frequency here to 100.8 hertz, megahertz, sorry. You are changing it to 100.8 megahertz. You change it to this frequency so that when you change the radio, your radio is now tuned to this frequency. What happens is, if you draw a graph, right, a graph of frequency, let's draw a graph of frequency against Z. Then of course you will see a curve that will similar with what I draw just now, something like this. Okay, so this is the graph of Z, which is equivalent to what, R square minus XL XL minus XC square. Okay, so when you have adjusted your frequency to 100.8 megahertz, right? Essentially, what happened is your impedance will be minimum at this 100.8 megahertz. Okay, so if your impedance is minimum, then you can probably expect the current to be maximum around this region. Okay, so if it's maximum around this region, so here the current is maximum, so you are able to listen to things being broadcasted but in this frequency clearly. Okay, can listen. But let's say for 87.7 FM, let's say hot FM over here, hot FM might be around here. So if hot FM is here, then the amount of current that is being generated because of this, under this frequency, the current is very low. Okay, so if the current is low, basically you can't hear it, so you can call it inaudible. Okay, so of course other frequency as well, let's say 102.4, this one also inaudible. Okay, so if you are changing the tuning knob, if you are rotating the tuning knob, so what you do is you are shifting the resonance curve. You are shifting the curve to this here, then you will now change your resonance frequency to 102.4. So at this moment, you might be able to listen clearly to 102.4 megahertz frequencies information, but not able to listen to other channels information. Okay, so that's roughly on how radio works, and I hope you are able to see this thing being applied in a modern you can call it, in a modern electrical appliances and how it works. Okay, so but let's get back to the question. So what is the capacitance of a capacitor when the radio is tuned to an FM radio station of frequency 100 megahertz? So you know that in order to listen to the FM radio station of 101 megahertz, what you need is you need your resonance frequency to be at 101 megahertz. So you know that the resonance angular frequency is equals to 1 over square root of LC. So you know that this is also equals to 2 pi resonance frequency, and it's equals to 1 over square root of LC. So now you can know that the resonance frequency is essentially just 1 over 2 pi square root of LC. So now we know that this frequency here is 101 megahertz. And we also know that the inductance for this circuit is fixed. And the inductance should be 2.5 microhenry. So what should be the capacitance at this, what should be the new capacitance? What should be the capacitance of the variable capacitor now? So if we move around, do a bit of calculation, we'll figure out that the capacitance should be at 1.00 times 10 to the power of negative 4 farad. Okay, so that's the capacitance that you should have for this capacitor over here in order to be able to listen to the FM radio station of frequency 101 megahertz. Okay, so that's the idea. So question B, what is the impedance of the circuit at this frequency? So if you know that the circuit is at resonance, what's the characteristic of this when the circuit is at resonance? When the circuit is at resonance, we know that the impedance should be minimum. So if the impedance is minimum, we know that the minimum value for impedance will be just equals to R. So if it's just equals to R, then we know that the impedance should be 200 ohm. The inductive reactance and the capacitive reactance will cancel out because one will be pointing up, one will be pointing out, they will cancel out. So what you are left with for impedance is just the resistance, and the resistance is fixed to be 200 ohm. Okay, so question C. Explain why broadcast from the FM station can be heard loud and clear. When the circuit is at the resonance frequency of 101 megahertz, what happens is the impedance is minimum. At 101 megahertz. So if you have a minimum impedance, because you know that Vrms is equals to Irms of impedance and impedance, you know that Irms in the tuning circuit will be maximum. So if you are able to have maximum current at this particular frequency, of course you are able to listen more clearly to the broadcast. You'll be able to listen to the information being carried by the wave at this particular frequency. There's a lot of detail that I brushed under the table, but the idea of this question here is just to show you that the tuning circuit consists of an RCL circuit actually. So by manipulating the C and the L, you change the resonance frequency in order to match with the frequency of the radio station that you are trying to listen to. Okay, so that's it for this question. Thank you very much.